Dr. Sarah Berry, can you give me a little bit of an overview over what you've spent the last sort of 25 years of your career focusing on and understanding?
Yeah, so I've spent 25 years starting out in quite a specific area, looking at how diet impacts our cardiometabolic health. So by this, I mean lots of factors related to cardiovascular disease, like type 2 diabetes, our cholesterol, our blood pressure, our inflammation. And then more recently, I've been looking at how actually we piece together all the complexity of who we are, what we eat, how we eat, into how that actually impacts how we respond to food and the helpfulness of a food. Most of my work's been done through running clinical trials, so randomized controlled clinical trials where I recruit various people, get them to eat various things, do loads and loads of different measurements and look at how a food or a nutrient or a diet might impact a particular health outcome.
And how many of these individual pieces of our sort of health and lifestyle are you trying to piece together to form this picture? What are those pieces?
The key pieces are who you are.
Mm-hmm.
So it's one of the key pieces. So by that, I mean your genetics, your microbiome, your age, your sex, your menopause status, all of those kind of things. The other is the food that you eat. And when we think about food, we need to think about it beyond the traditional way that we thought about food in terms of nutrients, back of pack labeling, fat, protein, fiber, carbohydrate, but actually thinking about food in terms of the fact that on average, each food has 70,000 different chemicals. And these are contained within a very complex food structure, which we call food matrix, that modulates the impact that those chemicals and nutrients have. So that's the second thing that we need to think about. So we've got who you are, the food that you're eating, but the complexity of that food, and then how you eat your food. And by how you eat your food, I'm thinking about your lifestyle. I'm thinking about, are you jet lagged?
Yeah.
How much sleep did you have last night? What's the order in which you're eating your food within a meal or over the day? How stressed are you feeling? When did you do physical activity? All of that also impacts how you will respond to a food. And then I think the last piece of the puzzle is so important that as nutritional scientists, I don't think we think about enough. Why do you make the dietary choices that you make? So why do you choose to have that for breakfast, for lunch, for dinner? Is it because it's part of your culture? Is it because that's how you're just feeling emotionally? Is it because you're sitting with friends and it's part of that social experience?
Mm-hmm.
I think we're at a really exciting time in nutritional research because we're now able to collect data at a scale, breadth, depth and precision that we've never been able to before, that's allowing us to put together all of those pieces of the puzzle to start to see a clearer picture.
So let's go into all of that. Let's start with the subject of the food matrix, which is a term I hadn't actually heard before until today. What is the food matrix and why do I need to know about that?
So the food matrix, simply put, is the structure of food. And it's really important because we know that food is so much more than just the nutrients and chemicals it contains. So we know that food contains nutrients that people are very familiar with, like protein, fat, fiber, carbohydrate. We know that food also contains thousands of other chemicals. Many of these we call bioactives that you'll have heard of, like polyphenols, vitamins, minerals, etc. But they're all encapsulated within the structure of a food. So think of an apple versus apple puree versus apple juice. They're all coming from the same food, but they have a different structure. And the reason it's important is because we know that food structure modulates the helpfulness of the chemicals and nutrients within the food. And it's really, really relevant now. It's really relevant now because our food landscape has changed almost unrecognisably to 50, 100, 200 years ago. We're now eating a lot of food where the food matrix, the structure of the food has changed. And this is because we use multiple different processing techniques.
So in simple terms, if I were to zoom in on a piece of food on a microscope,
Yep.
the way that the molecule of the food is put together is now different to what it used to be, and that's having an impact on my health?
So in simple terms, it's that we are changing often through processing the structure of the food. Now, by processing, it could be our own processing. When we chew a food, we change the structure. Take a nut, for example, you have a whole nut, you chew it, you break up the nut, it goes into your gastrointestinal tract, it's broken down further. We also change it using manual industrial techniques as well. So we use techniques like grinding, or we might use pasteurization for dairy, or, extrusion for some carbohydrate-rich foods. We use all of these different techniques that also change the food matrix. And I think this is what we need to remember, that everyone's demonizing at the moment. Ultra-processed food, it's killing the nation. 60% of our energy is coming from ultra-processed food. Yes, we are eating too much unhealthy food, much of which has been heavily processed, but processing can also be used to our benefit. And we have to think, why do we even process food in the first place? Well, we process it to make it edible. Mm-hmm. I don't want to go and eat a rice grain that's not been cooked. We make it safe. I want to drink pasteurised milk because I know it's safer. We want to make it stable. I think how long a can last and frozen vegetables versus fresh. So you're saving food waste. We want to make it taste good. Mm-hmm. And we want to make it convenient. So there's all of these different reasons that we use food processing. But when we think about the healthfulness of a food, we need to think about it in terms of the processing techniques that have been used, as well as the nutrient composition. We can't look at them in isolation, in my opinion. And this is what I've done a lot of research looking into.
And what is processing gone bad?
I think processing gone bad is when you've changed the nutrient profile of a food such that it is unhealthy. So in simple terms, it's too much saturated fat, too much salt, too little fibre, too little bioactives like polyphenols, a food that is very energy dense. So you eat it really, really quickly. So you're eating too many calories. You're eating it before your hunger signals have got to your brain to say, whoa, Stephen, you've had enough. And there's great research that has been looking at how processing can affect your eating rate, the energy density of food, the nutrient profile of a food. And that's where it can go wrong. But where it can go right is you can improve all of those things that I've said, the stability, the safety of the food. You can also increase what we call bioaccessibility, so the availability of some of the nutrients within a food as well.
Okay, so I've got some snacks over in the corner of the room here. Some nuts here.
Yep.
And I've got some cookies, some little pieces of chocolate, and some crisps. So you were talking about this processing something so that I eat it faster, mm-hmm. and that it doesn't sort of satiate me or make me feel hungry. Crisps. We're a nation of crisp lovers. When you were saying that about something that makes you eat fast and not realize that you've even eaten it all, crisps were the first thing that came to mind for me.
I love a crisp.
You love a crisp. We all love a crisp.
So I think all of these first three foods, the crisps, the chocolate, the cookies, if compared to what would be a healthy food, they've all got less fibre. Mm-hmm. They've all got, certainly that won't have all of the wonderful bioactives in them. And then with the crisps, depending on the type of crisp, it's probably quite high in salt. But the chances are with those three is that they are quite energy dense, so they have quite a lot of calories per gram, mm-hmm. which is partly because of the processing techniques. Yet if you take a whole food like a nut, now they're actually very energy dense. So they're very high in fat, they're high in calories. But actually, because they're in their original food matrix, how your body handles them is quite different to if, for example, they had been processed.
You mentioned something about my brain takes a little while to figure mm-hmm. out that I've started eating.
Yep.
So if I started smashing these crisps down now,
yep.
how long would it take my brain to realise that I'd started eating to sort of catch up and make me feel hungry?
Yeah, so there's lots of different mechanisms that impact how full we feel, how hungry we feel related to a food. There's different hormones that are released from different areas of our gut, for example, that feedback signals to say either you're full or you're hungry. On average, I would say it takes about 10 to 20 minutes for the fullness to really properly kick in. Mm-hmm. Now, you could easily have got through those. Well, I could easily have got through all of these mm-hmm, in under that 20 minutes.
I wasn't aware that there was a delay, but it does make sense because there's certain foods that I used to eat, like Pringles and snacks and crisps and things like that, where I feel like I could eat 2 tubes of the thing before my body even realised what was going on. And are they in some way designed to encourage that speed of eating? And
so there are many people who will say the food industry has specifically designed these to make them firstly what we call hyperpalatable. So to have the right mix of fat, sugar, carbohydrate, etc., to make them really tasty, and in this case salt as well. I don't think the food industry is out there to get us. I think that what the food industry were doing 50 years ago versus what they're doing now is quite different. But some people will say I'm very naive. I do believe the food industry ultimately want to produce food that's safe but also healthy for us. That's probably an unpopular opinion, but based on my interactions with the food industry, I believe that. However, I do believe that these crisps have been made to be flavoursome, to be palatable to you, so that you do enjoy them. Now, whether that's that you then go and overeat them, I think is, yes, a byproduct of that. Now, it doesn't take 20 minutes for all of the fullness signals to kick in, because as soon as you start chewing something, you start to release different hormones, and different sensory characteristics of the food will also trigger some sort of fullness. But what we do know is that you have more of these fullness receptors saying, hey, you're full, lower down in your gastrointestinal tract. And so if you can get food to the lower gastrointestinal tract, that's when it says, hey, Stephen, you're full now. And these heavily processed snacks that you've got here would be typically absorbed higher up the gastrointestinal tract, because kind of the hard work's been done. And yet when you've got something like a whole grain or a nut, typically that would be absorbed lower down the gastrointestinal tract, where you've got more of these fullness signals, so giving you that greater feeling of fullness.
My girlfriend has said to me for many, many a year that I need to eat slower.
Yep.
And I thought it was like a spiritual thing that she's into, to do with like giving the food gratitude, et cetera, et cetera. But upon reading your work and having this conversation today, now I'm starting to believe that she was right all along, unsurprisingly, once again, and that there is a scientific basis for slowing down how fast I eat.
Absolutely. We now know that eating rate's important. There's some fantastic work that's being done by a Professor Kieran Ford, who's dedicated many years into researching this and looking at how changing the structure and texture of a food can modulate your eating rate, and how also your eating rate can modulate how you metabolize the food and how many calories you go on to eat. And so it's a great example. I talked about all of these different pieces of the puzzle. That's one of those pieces. So when we talk about how you eat, changing your eating rate, so how quickly you have your breakfast, your lunch, your dinner, or any of these snacks, will also, without you consciously thinking about it, change how many calories you eat, might change how quickly you metabolize the food as well.
What's the sort of knock-on effects there?
So the research that's been done by Kieran Ford shows that on average, if you change the speed in which you eat your food by about 20%, you reduce your calorie intake by about 15%. And that's due to where you're releasing your hunger hormones, how many fullness hormones you're releasing, etc. So it's a really simple strategy. And we see this play out as well, even in our own evidence, when we look in our Zoe Predict studies at fast eaters versus slow eaters. We see that once we adjust for lots of other confounders, there's a difference of 120 calories between what fast eaters have over a day versus slow eaters, with the fast eaters eating more calories compared to slow eaters. And there's even been clinical trials where they get groups of individuals and say, okay, slow down the rate at which you eat your food over the next, 3, 4, 5 weeks. They have another group, they say, just eat at your normal rate. Those people who are intentionally slowing down the rate at which they eat their food lose more weight than those people who continue to eat at their normal rate.
See, I always made this like weird, unfounded evolutionary argument to her. I was like, well, in the wild, you got to eat what you can. So people eat quick, but we're not in the wild anymore, and the food choices that we have are drastically different now. So
yeah, and also the food that is available to many of us is the kind of food that can be eaten really quickly. So there's some great research that's been conducted that shows that heavily processed, soft textured type food can be eaten 50% more quickly than the unprocessed, harder textured equivalent. So the kind of food that we're eating now is quite different. So you're eating it really quickly. You're overeating because your hunger signals haven't got there, but it's that rate at which you're eating.
What's an example of a soft textured food versus like a hard textured food?
So we can use an example from a study that was actually conducted in 1977, and this was published in The Lancet. It was one of the first nutrition studies published in The Lancet. And it's one of the first studies to show the importance of the food matrix. And it kind of got buried for many years. And it's a study by the scientist called Haber, where he fed individuals whole apples. Mm-hmm. He fed individuals the equivalent amount of carbohydrate from apple puree. It was exactly the same, i.e., same nutrients, same fibre, same everything else in it. All that's different is the apples are hard, the puree is soft. And what he found was that those people who were given the puree, even though they were given exactly the same amount of calories, ate that puree, or rather drank that puree, 3 to 4 times more quickly than when they had the apples, the equivalent amount of calories. So they were eating the same amount of calories, but 3 to 4 times more quickly.
That's like 300%, 400% faster. Okay.
They felt less full. So when they measured their fullness, and they monitored that for quite a few hours, so going up to quite a few hours, those that were having the apples continued to feel full for longer. Those that were having the puree didn't feel full as long. And what also happened, interestingly, is those that were having the puree had what we call a blood sugar dip. So about 2 to 4 hours after having a high carbohydrate meal, we know that some people have a dip in their circulating blood sugar. And we know from our own Zoe Predict research that actually this can really increase your hunger levels.
Yeah.
And so we know from our research, if you are a dipper, I'm a dipper, hence I get hangry quite often. So in about 2 hours, I'm going to be eating one of these. If you're a dipper, you know, your blood glucose is going below your baseline levels. And so you get hungry, you go on to eat 180 calories on average more at your next meal because of that. And so, I mean, this research from 1977, I think is fascinating. It's that first research really demonstrating the importance of food matrix. And then since then, I've now, over the last 10 years, done lots of studies with nuts, with oats, for example, that demonstrate you can have 2 foods that have identical back-of-pack labelling, identical nutrients, identical calorie value, if you were to look at the back-of-pack labelling, but can have entirely different impacts in terms of how much energy you absorb, how you metabolize that food, how it impacts your hunger, how it impacts downstream health effects.
And you've done some research on walnuts, right?
So we've done work on walnuts,
Almonds.
but particularly on almonds. So we've done lots of work with almonds using it as a kind of proof in principle of the importance of the food matrix. Now, you just took a bite of that and I could hear the crunch. Mm-hmm. The reason I could hear the crunch is because in almonds, like most nuts, like many plant-based products, there is a very rigid cell wall. Okay, so that almond that you're holding there has thousands and thousands and thousands of cells. These cells are tiny. They're about 50 microns. Okay, you can't see them with the human eye. I can show you a micrograph.
Okay.
But there's thousands in there. Now, each of those cells is smaller than a grain of sand. And each of those cells cell walls is encapsulating the fat. So we know that in most of these nuts, it's about 50%, they're about 50% fat. Hence people say, oh my gosh, I can't eat nuts, they're high fat, they're high calorie. Now, in all of those nuts, the fat's encapsulated in this rigid cell wall. When you bit that, you fractured some of those cell walls. When you swallow it, you chewed it a little bit, I assume?
A little bit. Yeah, I didn't swallow it.
When people chew it, we know from these lovely chew and spit studies or mastication studies that we do that at the point at which you swallow a nut, the particles, i.e. the size of the bits that you're swallowing that you've chewed, are about maybe 0.5 millimetre to 1 millimetre in size. Now, given that the cell within of a almond nut is about 50 microns, that means when you're swallowing, within that what we call a macroparticle, you've still got thousands of cells. They're intact, where you've got this lovely cell wall containing all of this fat. And so you're swallowing these intact cells containing, encapsulating the fat. So they're what we call very low bioaccessibility. They're not very accessible to us, this fat. Now, what happens is this passes through your gastrointestinal tract. Some of the enzymes can break down the cells a little bit, but actually a lot just comes out the other end. So I don't know whether you've ever eaten a bag of nuts and looked at your poo after.
None of your business. I'm joking.
Okay, go and do that. But you should see some almond particles.
Really?
Like when I'm, being a mum, when I've looked at a lot of poo in my life through my work, but also through being a mum,
I bet.
you can see whole nut particles in the poo.
So nuts, they just don't break down fully?
So they break down partially. So you break down about 10% in the mouth before you swallow. So about 10% of the calories become available because the calories are contained from the fat, etc. And then you probably break down about another 60 to 70% as it passes through your stomach, your small intestine, your large intestine. Okay, but you have loads of material arriving at your colon, which is your large intestine, that's undigested, which is good for two reasons. One, because you're giving all of this food to your microbiome, which we know is great for your health. Your microbiome's having a party with these nuts. But also, if you are worried about eating nuts because of their high calorie value, actually 20 to 30% of the calories are just coming out the other end. But where it gets really interesting is if we then take exactly that nut that you're holding there, and if I was to industrially grind it so that I broke all of those cells' walls, So we're breaking it down to less than 50 microns so that you're releasing all of the fat. So it becomes 100% bioaccessible, i.e. you absorb 100% of it. But they could have two identical back-of-pack labels because they're the same ingredient. All that's happened is you've ground that nut to such an extent that you've released everything. And so having that in its whole form is beneficial because if you are concerned about energy intake, it's reducing the energy. It's providing this amazing food for your gut microbiome. It's changing also how your blood changes metabolically in that about 8 hours after eating it. And this is what I've done lots of work on, looking at how your blood fat increases and decreases in that immediate period after eating either ground nuts or whole nuts. But once you grind it, I'm not saying it's necessarily bad, because the upside of that is all of the other good nutrients contained within that cell, like the vitamin E and some of the other components, also become available. So it's this double-edged sword.
Interesting.
But that's what I think is so fascinating about processing and about food matrix, and why we have to move beyond thinking about food just in terms of the nutrients, because you can have two foods with identical back-of-pack labeling that have different effects. And we've seen the same with oats. We've been doing studies as well where we feed people large oats, so kind of, like the steel cut sort of old-fashioned porridge, or you feed people finely ground oats. And so we've done clinical trials where on one occasion people come in and they'll have 50 grams carbohydrate for breakfast of these large oats. Then they'll come in another day and they'll have exactly the same oats, but where we've ground them. Literally, we've got students just grinding them down so they're more like a powder. And the difference in the metabolic response in that following 6 hours after having either the large traditional oats or these finely ground oats is enormous.
And that's because of gut absorption speed?
Yes. So with the nuts, what we're seeing here is a difference in the amount as well as the speed. With the oats, what we're seeing is a difference in the speed. So we're seeing a difference in the rate, because we know that the food matrix impacts the amount, i.e. with the nuts, the rate, i.e. with the oats, and as well as where the food's absorbed in the gut. And so you see about a 40% difference in the postprandial glucose response. So this is the increase in circulating blood glucose after you've had these oats. We see about a 50% higher response from the ground oats versus the large oats. And that has subsequent impacts on hunger hormones, fullness hormones, insulin release, etc., etc.
And what role does fibre play in this? Because fibre is becoming quite popular now. They're like putting it in drinks and stuff like that. And there was some candy in America when we were recording over in New York, which had it said 15 grams of fibre added to this candy.
So fibre is a really interesting one. And it's a really interesting one because we know we're not getting enough fibre. So we should be getting at least 30 grams of fibre. In the UK, and it's similar in the US, we get on average about 20 grams of fibre. 95% of us are not having enough fibre. Fibre is the one nutrient that we know consistently is associated with beneficial health effects, reduction in many cancers, reduction in cardiovascular disease, reduction in levels of obesity, type 2 diabetes, etc. It's an amazing nutrient, fibre, and we don't get enough of it.
Just to pause there then, why is it so good for us? Because, it sounds like a super molecule the way you just described it?
So it's good for us for many different reasons, and there's loads and loads of different types of fibre, and the different types of fibre are good for us for slightly different reasons. Really simply put, we've got soluble fibre, and that's great for us because it impacts things like cholesterol absorption, as well as other factors related to how quickly we metabolize food, etc. Then you've got insoluble fibre, which is the kind of fibre that, for example, are in those nuts, because fibre in those nuts is actually the cell wall. So most cell walls of plants are just fibre. That's great for us because it's food for our microbiome. It helps bulk out our stool, so it reduces our transit time, how quickly our poo basically passes through our colon, reduce the risk of colon cancer and so forth. But largely because it is the food upon which our microbiomes have their party, produce all of these wonderful molecules that we know impact so much related to our health. But we don't get enough of it. And we don't get enough of it because we're not eating the right types of food that we have in high amounts. So having any kind of fibre is going to improve our health. Having fibre that's added artificially back into food is going to be better than having no fibre. So the kind of bars that you're talking about that say are added fibre, great. Having fibre, though, from the whole food is always going to be better. And so with nuts, fibre is essentially the cell walls of the nuts. So it's having that role in reducing that bioaccessibility that we talk about, at slowing those nuts down. So that's always going to be better, having that fibre in the whole food, in its original structure, in the way nature intended. But having any kind of fibre is better than having none. And in a nation or many nations where we're not having enough, if we can get some in our diet, even if it is processed fibre, it's better than no fibre, in my opinion.
One of the big revelations in my household has been just getting some of these bad snacks just out the house and replacing it with healthier whole snacks. And I say that because the sort of the very definition, the very like sort of use case where we snack is when we typically don't have a lot of time, where the hunger kind of crept up on us in between a meal. And so we make fast decisions. It's not a very considered decision. And I was reading that there's been some studies done where they took sort of two groups and gave them typical snacks versus healthy snacks, and they found a pretty significant reduction in cardiovascular disease.
Yeah, so this is one of my studies.
Okay.
And we looked at how changing people's snacks can impact their health. And the reason we're interested in this is because we're a nation of snackers in the UK, as in many countries. So we know that about 25% of our energy comes from snacks. That's phenomenal. And so what we wanted to do is look at, if we do a really simple snack swap, can we improve people's health? And so we asked people to change 20% of their energy from either having typical UK snacks or having 20% of their energy from almond nuts for 6 weeks. And then we looked at various health outcomes at the beginning of that 6 weeks and then at the end of that 6 weeks. We said keep everything else the same. We provided all of these snacks to them. We provided the typical UK snacks. We spent a lot of time designing these. So we did lots of research where we looked in the UK, and it's very similar in the US, what are the typical snacks? So basically we designed these muffins that ultimately were having a bit of a potato chip or crisp, a bit of a chocolate biscuit, a bit of a cake, just like imagine all put in one muffin. I mean, we didn't go and get those and just stick them in one muffin, but we worked out what's the nutrient profile in the UK, in the US that comes from snacks. And then we designed a snack product that was quite highly processed that reflected that nutrient profile. So it's quite high in saturated fat, high in sugar, high in refined carbohydrate, low in fibre. People had to eat 20% of their energy from these muffins, which my kids loved, or 20% from the almond nuts. At the end of that, we measured lots of health outcomes, one of which was a particular measure that we do to look at people's vascular function, so their blood vessel function. It's a measure called flow-mediated dilation. It tells us in really simple terms kind of how healthy the blood vessels are. And what we found was the improvement in blood vessel function following having almond nuts versus having typical UK snacks equated to a 30% reduction in cardiovascular disease.
That's crazy. In what period of time?